We are incomplete with our cost, na? We are incomplete with our cost chapter. Can you remember? Can you remember anyone that this is microeconomics class? We are discussing with production, cost.
Yes, ma'am. Yes, ma'am.
Okay, at least someone. Uh, so in our syllabus, we have discussed with the intertemporal choice, reveal preference, choice under uncertainty. That much is done. We are dealing with unit 2, that is the production and cost, and we are at the end of that unit 2, that is 2.3, cost structure. We were discussing with the cost, different type of cost, short run, long run, and all this. Then after we have to discuss about the perfect market, that's the perfectly competitive market structure, and the input market under perfect competition. Yes. So actually we have finished up to 50% of our syllabus. So 50% is left. Let me share my screen. If you can remember, we are dealing with the cost. Yes. We are dealing with the cost, different type of cost, short run cost, that is the marginal, average, variable, average, fixed cost, the relationship between the average and the total cost concept. These are the cost curves. The shapes, we have discussed about the shapes of AFC, AVC, AC, MC, the relation between ACMC, relation between AVCMC, and this is the set of the short run cost curves, average and the marginal cost curves. This is the mathematical relation between AVC and MC, mathematical between AC and MC. Now we are at the long run cost, and we said in the long run cost there is no fixed cost, so all the costs are variable. So there we have introduced the concept of ISO cost, and then the cost minimization, the equilibrium condition, mathematical derivations, a simple Lagrangian way. And then this, I have discussed some problems as well. If it is fixed coefficient production function, then what will be the shape of the total cost curve? This is actually the isoquant. And the ISO cost. So you have your K star and L star. If you put those, then you will get your cost function. Then the LAC and LMC, the mathematical relation between LAC and LMC. The new concept of functional coefficient. And then we introduce the returns to scale, right? Returns to scale and the relationship of the returns to scale with the functional coefficient. So this is the mathematical derivation. We have done a lot. No, we have done a lot of mathematics under cost. So this is the long run average cost curve. Along the curve, you have all the returns to scale concept, IRS, CRS, and finally DRS. And then intuitive interpretations. Expansion path. We have introduced the concept of expansion path. Then isocline. And this is another problem with the solution. Expansion path, yes. From here we will start. So after, before starting the new things, tell me if you have any query with the cost. If you can remember, we have discussed cost at all. Any query with the cost? Then I will proceed and want to finish the cost today. No query. Okay. Everyone is quite silent. So let me go back to the definition of the expansion path. because today I am going to discuss about the relationship between the expansion path and the cost curve. That means how to get the cost from the expansion path. Expansion path is, by definition, expansion path is the combination of the cost minimizing values of labor and capital corresponding to the parametric variation of the output level. Hmm. That means if you change the output level, then you are shifting from the lower. If you increase the output level, then you are shifting from the lower ISO cost to higher ISO cost with continuous increasing in your total cost, and accordingly you will get the equilibrium points. If you just join all those equilibrium points, then you will get the expansion path. Okay, excuse me. Now here the ISO cost lines are parallel to each other. That means W by R, that is input price ratio, is constant. Okay, this is the precondition of the expansion path. So you have the expansion path, you have the again you have the isocline. I'm not going there. So you have iso cost line which are parallel to each other, and corresponding to each of these iso cost, you have one equilibrium cost minimizing points. So joining all those, you are getting the expansion path. So I'm just repeating this diagram here. In the first diagram, this is the red one is the expansion path. Okay. The look at these blue lines, not the blue, the green lines. These are the iso cost lines which are parallel to each other, showing constant input price ratio, constant W by R. So your input price ratio is constant, your total cost is increasing. So that yellow lines are the iso quant. So they are tangent at these points. So this is the cost minimizing points. If you join all those cost minimizing points, that red line is giving you the expansion path. Okay, that is we have already discussed. Now from the expansion path, look, each and every green line is showing different total cost, right? So if you plot those total cost on the vertical axis in the next diagram, on the vertical axis it will be the total cost, and on the horizontal axis you will plot the different quantities corresponding to those isoquants. Okay, so on the vertical line total cost, on the horizontal line total quantity produced. Okay, so you just plot these values here, you will get that. I hope this is black one. This is the total cost. Okay, so total cost on the vertical line, total quantity on the horizontal line, horizontal axis. If you just join all those points from the first, if you plot all those points, cost minimizing points from the first diagram, you will get the second diagram, that is the total cost line. Okay, so this is how sometimes the questions are coming, how to get the cost curve from the expansion path. So this is the way to get the cost curve, total cost. This is obviously the total cost curve. Okay. Any problem with these two diagrams?
No, ma'am.
Then the next one. Okay. This is actually, I have just take a snapshot of my copy and then I'm showing you, maybe a bit hazy. If you have any problem with that, you can ask me anytime. Huh? This is the relationship between long run average cost and short run average cost. A bit tricky diagram. Try to understand it. Take your own time. Try to understand it. First of all, sometimes the long run average cost curve is called the envelope curve. Okay. So why it is envelope? So this diagram will explain the reason behind the name. Look, on the horizontal axis, we are measuring the quantity produced. On the vertical axis, we are measuring the short-run average cost and long-run average cost. Okay, so we are measuring both on the vertical axis. Now, this line is that flattered U-shaped line is the long-run average cost curve. And inside this line, you have 1, 2, 3, 4. 4 short run average cost curves which are tangent to LSE. First of all, they are tangent to LSE. First point. They should be they must be tangent to LSE. First point. The second point is, remember, when you will draw this diagram in your copy, you must remember one thing, that except SSE3, that is at the minimum of your LSE, all other SSEs are tangent to LSE, but not at the minimum of SSE. I'm repeating. Except SSE3, all other short-run average cost curves are tangent to long-run average cost, but not at their minimum point. Okay? Not at their minimum point. Only SSE3 is tangent to LSE at SSE's minimum point. This is obviously LSE's minimum point, but the two minimum points are tangent only here. No other places. No other places. Look, in case of SSE1, the tangency is here. The minimum of SSE is here. The minimum of SSE1 is here, but it is tangent with LSE here. The minimum of SSE2 is here, but it is tangent with LSE here. The minimum of SSE4 is here, but it is tangent with LSE at some other point. Do you get my point? So don't try to draw all SSEs tangent at their respective minimum points. No, the minimum is somewhere else. They are just tangent. Okay, they are just tangent to LSE. Actually, in my class, I used to draw that wrong diagram as well so that you can understand the difference. But I don't know whether I can do it here. Let me try, yeah? Let me try, just a minute. Let me try. Because I'm not happy if I cannot show you. Yes, where is the pen? This is your LSE, okay? This is your LSE. Don't consider all those abnormal shapes, because I'm very much new. That case. And say I'm going to draw the wrong diagram. Huh? I'm going to draw the wrong diagram. Look, generally some peoples are drawing. This is SSE1. This is SSE2. Okay. Obviously, that point will be always correct. This is SSE3. SSE3 is very much okay, but this is SSE4. Look, all the minimum points are, can you see my screen?
Yes, ma'am.
Okay. Now look, all the minimum points are here. Look, SSE's 1 minimum point is here. SSE2's minimum point is on the LSE. SSE3 is very much okay, but SSE4 is here. So this is wrong. Okay. This is wrong. Remember, this is wrong. Don't draw this. Okay. Don't draw this. This is something wrong. This is something wrong. Don't go for it. The actual diagram is like this. Huh? It is not at the LSE. It is somewhere else. Okay. Now look, what will happen? Okay. Okay. Let me draw another. It will take some time, but I want to clear it. Yes. you have, say you have two SSCs. Huh? You have two SSCs. One is here, another is here. Okay. This is 1 and this is 2. These are short run cost curves. Huh? Now look, why you have these two? Because in the short run, you know you cannot change your capital stock. You can change only your labor. So what is the implication of saying that your capital stock is unchanged? That means your technology is given. Once you change your capital stock, that implies you can change your technology. You can go for superior technology. You can implement some sophisticated technology. But as I am saying your capital is constant, that means I am restricting you of doing this. You cannot change your technology. Okay. So given the technology, given the capital stock, you may have SSC1. If you change your capital stock, you may have in the short run SSC2. Okay, so these are two short run average cost curves given the technology. This is for one technology, this is for another technology. Clear? So this SE average cost is for one technology, this one for another technology. But once you are considering the long run, in long run you can change your capital stock. That means you can move from SSC1 to SSC2. Okay, as you can change your capital stock, you can change your technology, you can easily move from here to here, right? Now, given this, is it clear to you? Is it clear? Any doubt? Are you listening?
No, ma'am. No doubt.
Oh, only Adeline is listening. Anyway, now look what is happening. In the long run, you can move from this to this, right? Now, given this, say you are trying to produce Q1. Hmm. Say you are trying to produce Q1. Okay? Say you are trying to produce Q1, right? Okay. Now, in the long run, you are trying to produce Q1. Now, as you can change your capital stock in the long run, you can change your technology. That means you can choose any of the SSC1 and SSC2. Now, my question is, in the long run, if I am asking you to produce Q1, what technology you will choose? 1 or 2? Not Adeline. Anyone other than Adeline. Which technology you will choose in the long run to produce Q1? 1 or 2? Anyone? Tell me what is 1 and what is 2? In my diagram, what is 1 and what is 2?
Ma'am, there is a network error. Can you repeat, please?
Which one to repeat?
No, ma'am, from that diagram was that diagram part.
Are you in my class? Because I am asking repeatedly. No one is giving answer. Anyway.
Yes, ma'am,
Yes.
from because there was actually network issues. I was facing network issues.
Okay. Now look on the vertical axis, I am measuring quantity produced. Okay. That one is meaning, the meaning of one is it is short run average cost one, SSC one. And two means SSC two. Okay. Now as your capital is fixed, that means along this SSC one, you are facing one technology. You are using a particular technology. Along SSC two, you are using another technology given the different capital stock. Okay, so each and every SSC is showing different technology. Clear? Now am I audible?
Yes, ma'am.
Okay, now I am asking, you are in the long run. So in the long run, you can change your capital. That means you can choose the technology. You can move from SSC 1 to SSC 2 or from SSC 2 to SSC 1. Okay, there is no issue. You can move because you can change your capital.
Yes, ma'am.
Now look, you are going to produce Q1 in the long run. In the long run, you are going to produce Q1. So I was asking that if in the long run you are going to produce Q1, which one should you choose? One or two?
Ma'am, I think the first one because the cost is lower than the two at that
Which
point.
type of cost? Which type of cost? Be specific.
Short run cost.
No, average cost.
Oh, sorry. Yeah. Yes, average cost. Sorry, average
So
cost.
average cost is lower in case of one than two for Q1. So here you will choose technology one. Okay.
Yes,
And
ma'am.
the same logic is true up to this intersection point. Up to this intersection point, right? At this intersection point, you are indifferent. At this intersection point, you are indifferent. Okay. Here you are indifferent. And then after, if I am asking you to produce a Q2, if I am asking you to produce Q2, then
We will choose the second curve.
you will choose the second one. But because here your average cost is less. So what you are doing actually, what you are just choosing, right? You are just choosing, you are moving. Where is my pen? Ja. Where is my pen? I cannot see my pen. Oh, yes, it is here. Now look what you are doing. You are just moving along the SSC1 up to this intersection, then after along the SSC2. If there is any SSC3, then you will move along this. So what in the long run, you are doing like this up to this, then this, then if you have any, then this, then this. So this is your long run movement, right? So this is how you are getting your long run average cost. So it is the combination of the short run average cost. This is for SSC 3. This is for SSC 4. This is how you are making your long run average cost. Now look, then your long run average cost is like the like a curve, this and then this like this. But actual in the reality, there are a lot of SSC curves. It's not like 1, 2, 3, 4. There are infinite number of SSC curves depending on the fractional change of your capital stock. So that means in the long run, you may have, and in the short run, you may have another curve here. You may have another curve here. So this is how that curvature of your LAC is becoming smooth and smooth. And finally, it becomes a flat one. Okay. Finally, your LAC is becoming a flat one because each and every point of your LAC has a lot of SSC. Hmm. So this is your LAC curve. Oh, Baba, just a minute. Actually, I'm struggling with this new technology. Where is my pen? Yes. This is your LAC. Hmm. Okay. So this is your LAC curve. So your LAC curve, each and every point of your LAC corresponds to a particular point of your SSC curve. Okay. This is how you are getting your LAC. Now look, your LAC is not like parallel to the horizontal axis always. It's actually a curve that you already derive. You already derive that LAC is actually a U-shaped curve, which corresponds to different type of returns to scale. Huh? So your LAC, your LAC is like this, that you already know. This is your LAC. It's not like a parallel is a line parallel to the horizontal axis as I have discussed. This is for just to explain the relationship between SSC and LAC, but this is not the real shape of your LAC. The real shape is this. So here you have a lot of SSC as I said, but remember only one thing, the SSC should be like this. The minimum should be somewhere else. The minimum should be somewhere else like this. The minimum should be on the minimum of LSE at the minimum of LSE, but no other. Okay, so this is how you are going to draw your SSC and LSE. Now look at your LSE curve. Now look at your now look at your my diagram. Here, if you just look at your LSE curve, it's just like some papers are inside, some curves are inside the LSE curve. Some you are keeping some small curves inside your large LSE curve. So it's just like you are keeping some papers inside one envelope. And this is why LSE is called the envelope curve. Envelope of infinite number of SSE curves. Okay. So sometimes like this question is very common if you go through the university question paper, that why LSE is called the envelope curve. So for that you have to draw this diagram, then explain the relationship between LSE and SSE, and then the conclusion is just like an envelope where a lot of papers are inside the envelope. In spite of paper, it is the curve. That is why the LSE is called the envelope curve. Okay. This is one thing I wanted to share with you, the relation between LSE and SSE. And the last one is here. Yes. I don't know how to increase the size. Do you know how to increase the shape? This is very difficult. Am I audible?
Yes, ma'am.
Ishan?
Yes, ma'am.
Okay. Anyone? I cannot increase the size. How? What to do? Help me.
Ma'am, there is a magnifying glass over the.
Yes. Very good. You all are such a tech-savvy person. Yes. Now look. Now look. Now I think it's better, now you can understand. This diagram is in the Pindak and Rubenfeld. Don't worry. There are two inks I am using. What is the heading of this diagram? The heading is derivation of the LMC curve. Okay, the derivation of the LMC curve from the SMC curves. It's a bit confusing, but don't worry. I am trying my level best to explain it. There are three. First of all, your LSE is the envelope cup. You already know. So there are three SSEs inside your LSE. SSE 1, SSE 2, SSE 3. Okay. Each and every SSE has SMC, that is the marginal cost curve, you know. Okay, and the marginal cost curve is intersecting the average cost curve at its minimum. Okay, so this is SMC1 corresponding to SSE1, which is intersecting the SSE1 at its minimum. Same is here, same is here. So you have SMC1 here, SMC2 is here, and SMC3 is here. Okay, done. Now look, there is one, try to remember the steps. Other things are very simple. Try to remember the steps. The SSE1 is tangent to your LSE at a particular point. Say it is here. SSC is tangent to LSE. Okay. At this point, you have to drop a vertical line from this point on the horizontal axis. Okay. It's Q1. Now, this dotted line is intersecting the corresponding SMC at a particular point, any point. Okay, so that point is a point of LMC. I'm telling you again, the SSE is tangent to LSE. From the tangency point, you have to drop a vertical line. Okay, that vertical line will intersect that SMC at a point. So that point where the vertical line is intersecting SMC is a point of the LMC. That means LMC must pass through that point, must go through that point. Okay. Now come at the minimum point. At the minimum point, everything is very fine because everything is tangent at a particular point. Okay. The LSE2 is tangent to LMC at the minimum point. So both the minimum points are a single point, and LMC is also intersecting that minimum point. Okay, SMC is also intersecting that minimum point. So you can understand everything is that point. So your LMC must pass through this minimum point of LSE. Now come to the last part, SSC3. It is also tangent to LMC at this point. Now, once you drop the line here, it will not intersect the corresponding SMC because SMC is above SSC for this portion. So you have to extend that line, the line from the tangency upward. It will intersect the SMC at a particular point. Again, that point will be a point of your LMC. So you have 3 points. One is here, another is here, and the last one is here. So if you join all those 3 points, actually you may draw a lot. You may draw a lot of SSC, but it will be a clumsy, a bit confusing. And your pin dial, there are also these 3 SSCs. But if you want, you can draw a lot. So if you just join 1, 2, and 3 points, you will get your LMC, that red line. The red line is your LMC curve. Okay, it is very similar to SMC. All the properties of SMCs are there in LMC. But how to get the LMC is a bit tricky. Once you can understand the steps, it will be easy. Now tell me, do you have any problem with that?
Ma'am, can we do that? We can draw LMC and LAC first, and then SAC and SMC, because that will be easy.
Yeah, that is back calculation and there is no logic behind that. But just to make it a neat diagram, you can draw it. But when you will explain the steps, don't explain in your way. Explain in this way.
All right, ma'am. And ma'am,
Is
is
it
it that LMC cuts the LAC from its minimum point?
That is what I'm saying. All the properties are there. Same properties.
Okay, ma'am.
SMC is intersecting SSC at its minimum. LMC is also intersecting LAC at its minimum. U-shaped. Everything is same. But the derivation is something different. Okay. So I have finished my production and cost. I will discuss perfect competition in the next class. I have next class with you tomorrow at the same time. I hope so. And I have shared all the class links with you yesterday. So I hope you can understand your timetable with the microeconomics class. So I will start perfect competition tomorrow. Before starting, I will ask you if you have any problem with the production cost because we did it 2 months back. Then after you have to give your same two exam and a lot of more things. Winter recess is also there. So all these things are there. It's quite possible that you could not remember anything. Just read it. You have 1 day in your hand. If you have any query, ask me tomorrow. And then after, I will start the new class. Okay. As this is the first